Ang susunod na programa ay rated G. Ito ay pwede sa lahat ng manonood.
If you can't smell, you probably can't taste very well either. They are closely related functions. Receptor cells for taste and smell are located in the mouth and nose, respectively. As the receptor cells are stimulated, they send impulses from these organs to the brain's smelling and tasting centers in the cortices. For taste, impulses stimulated by the chemical compounds in food are sent to the gustatory cortex. For smells, impulses stimulated by chemical compounds in odors are sent to the olfactory cortex. As new compounds stimulate the receptors, the brain forms an odor memory bank so that it can recall the odors the next time they are present.
Your tongue is covered in tiny little bumps called papillae that each contain many taste buds. Chemicals from the food dissolve in our saliva before they enter our taste bud through the taste pore. These chemicals will then reach the receptors of the receptor cells. Different chemicals give different tastes. A taste bud contains several taste receptor cells. Each receptor cell is more sensitive to a certain flavor. At the end of each receptor cell is a tiny hair that can sense the chemical from the food. When a chemical enters your taste receptor cells, the taste receptor sends a message to the brain via the afferent nerve. The brain processes the messages it receives and allows us to perceive the taste of food. Do remember that our taste buds do not taste, they only send signals to the brain. It is your brain that's responsible for taste. Olfactory receptor cells are like taste receptor cells, but they are found in the uppermost part of the nose. The receptor cell also has tiny microscopic hairs on one end and is connected to the brain on the other end. Different smells produce different chemicals that enter our nose when we breathe in. The microscopic hairs on the olfactory receptor will detect the chemical. The receptor will pass a signal to the brain for processing. Our brain processes the signal from the nose and allows us to perceive smell. Without it, our nose can detect chemicals, but we will not know what we're smelling. Our sense of taste and smell work together to enable us to enjoy food. The parts of your brain that control smell and taste are closely linked. When you chew food, the food releases certain odor chemicals that travel up your nose from your mouth. This causes your brain to receive messages from both taste and olfactory receptor cells.
Why do people have different reactions to the same food? One person might love chocolate, while another person may find it too sweet. Some people love cheese, but others just think it's nasty. The reason for these differences is due in large part to the taste of food, but there are other factors too. The smell of food, its texture, its color, and its temperature also contribute to what's generally known as the flavor of food. The combination of all these factors tells us whether food is delicious, good, unpleasant, or downright disgusting. The flavor of food is due mostly to how it tastes and smells. When you eat, the most immediate sensation is taste, but you actually smell food as well. If you hold your nose while you eat, you'll notice that some foods will taste different. There are 5 taste sensations: sweet, bitter, sour, salty, and umami. Only recognized as a taste in 1985, umami is associated with savory foods, which includes meat and tomatoes. Smell is as important, if not more important, than taste. For instance, when people who have a head cold try to taste salsa and chips, they feel the textural crunch of the chips and the tingle of the hot peppers on their tongue, but they cannot taste the flavor-rich salsa with its onions, tomatoes, and peppers because they can't smell it. When we chew, aromas are released that activate our sense of smell by way of a special channel that connects the roof of the throat to the nose. If this channel is blocked, such as when our noses are stuffed up by a cold or flu, odors cannot reach sensory cells in the nose that are stimulated by smell, so we don't enjoy foods the same way. Without smell, foods tend to taste bland and have no flavor. A huge amount of chemical compounds contribute to the flavor of food. Chocolate, for instance, is a mixture of some 300 flavor compounds. and coffee beans contain more than 800 chemicals. Identifying these chemicals can help create a variety of artificial flavors that are used in nearly every food product out there, including potato chips, ice cream, chewing gum, and soft drinks. Chemists create artificial flavors from chemical compounds present in plants and animals. They use them in their natural state, or they process them to make new flavors. What's interesting is that we don't need all the flavor compounds in a given food to recreate its flavor. For instance, an orange contains 250 flavor chemicals, which all combine to create an orange flavor. But artificially flavored Tang, a powdered drink mix, has only 6 aromatic chemicals in its makeup, but it has a familiar orange-like taste. So we can get pretty close to proper orange flavors from just a few of its flavor chemicals. Artificial flavors get their characteristic odor from various compounds, especially esters, which are chemical compounds formed by the chemical reaction of an alcohol with a carboxylic acid. An alcohol is an organic compound with the general formula ROH, in which the R is a hydrocarbon group and the OH is a hydroxyl group. A carboxylic acid is a compound with the general formula RCOOH. For example, the formation of ethyl butanoate, one of the compounds that gives pineapple its flavor, is produced through the reaction of butanoic acid with ethanol. But wait a second, isn't ethanol the type of alcohol found in alcoholic beverages? That's true, but when it combines with the acid, it loses the characteristics of drinking alcohol. Likewise, acetic acid is the main component in vinegar, yet when it reacts with an alcohol, the flavor changes dramatically. When 2 compounds react to form a new compound, the properties of the new compound are not a simple combination of those original ones. They are completely different. If you use different alcohols and different acids, you obtain different flavors. You can compare that to combining 2 colors of paint. When you combine red and yellow, you get orange. Similarly, when you combine pentanol with acetic acid, you get pentyl acetate, an ester that smells a lot like a banana. Flavor chemists combine many chemicals to achieve a desired scent. Day after day, they test different combinations before settling on the one that will achieve the desired result. But don't expect to get a tour of a flavor and fragrance factory anytime soon. Those flavor formulas are carefully guarded industry secrets. At major food companies, you have to work as an apprentice chemist for 7 years before even getting a peek at the flavor formulas behind the world's most popular food.
Flavor is really the combination of taste that we taste with our mouth and smell that we smell with our nose. And the brain takes these sensations from our mouth and from our nose and processes the information and creates what we define as flavor. There are the 5 basic tastes: sweet, salty, sour, bitter, and umami. And taste is hardwired from birth. So when we're first born, we can detect these different tastes. But smells are something that we learn through experience. And humans can detect greater than 10,000 different odors. Also, we find that smell by far is the greatest contributor to flavor overall. When the brain processes taste and smell, smell is the dominant factor. In fact, we humans have a tremendous sensitivity to smell. We can detect things at as low as 1 parts per trillion. There are 3 primary sources of flavor in food. There is naturally formed flavors, and these are the ones that are formed by enzymes in plants, especially in fruits. There are those that are physically initiated. These are flavors that are created, especially in plants, when we chop them up and disrupt the cells, and substrates come in contact with enzymes and form new flavor molecules. And then finally there is the reaction-derived flavors that occur during cooking, especially through heat and oxidation.